Welcome to EDU World Space.
To demonstrate the desired comparison, we'll just use a rough sketch. Our graph for 1 over x to the 1.3 power looks something a little bit like this. Probably a little bit steeper, but for the sake of this, it's not too important. Now, if we mark this as 1, and so on, when we're talking about our series, those are all going to be width 1 rectangles, starting with the height at 2, since we're starting with n equals 2. So that would be a rectangle, something like this. We have another rectangle here, and so on. However, the integral itself is the entire area underneath the curve, which, starting at 1, means we would include this area in addition to that of the rectangles. So we can see right away that for each subinterval, there's a little bit that gets missed by the series that the integral itself picks up. So clearly, the area of the rectangles for our series is less than the area of the integral itself. Now, as far as what we can conclude about the series based on this information, we can see if we actually evaluate that indefinite integral. If we take this integral using, of course, a limit, since this is an improper integral, we'll eventually see that this integral does, in fact, converge. We do a little bit of magic and we get negative 10 over 3 times 1 over t to the 1.3 plus 10 over 3, which as t goes to infinity, this term becomes 0, and we are left with just 10 over 3. Since the integral itself converges and the series is less than that of the integral, or has a lower value than the integral, the series itself must converge.